Problem number 3, a soccer ball is kicked up a hill and it bounces multiple times. They didn't say whether it's elastic or not. And the request is to show the vertical component of its velocity as a function of time. The solution is all right, but could be more clear. They say that Vy should be decreasing with constant slope everywhere except at the collisions, ruling out all but choices D and E. It's not super clear because everybody has a linearly decreasing part of the curve. The only distinction between the first and the second row is that the second row has a instantaneous jump of velocity at collision, and the top row has a gradual change in velocity that takes a certain amount of time. And the D and E correctly describe the collision. This can be more easily seen in this diagram here. If a ball bounces from a horizontal surface, whether it's elastic or not, you can see that the Y component indeed has an instantaneous change at the point of collision, whereas the X component is continuous. Another interesting point is that solution D, besides the velocity not decreasing over time, that's why E is correct. But another interesting point is that the change in velocity has about the same magnitude, right? It changes from minus V to positive V, and it's about symmetrical with respect to the Y, to the x-axis. Look at solution E. It seems that when it bounces to the positive velocity, the magnitude becomes a little higher. That may be counterintuitive, but it's probably right. If you take this horizontal collision diagram and rotate it, and this pretty much describe what happens in a slope, you can see that because of the tilt, and we're only asking for horizontal velocity, you can see in this case, the velocity that comes in is pretty flat, and the velocity leaving the collision is pretty vertical, so it's probably right that most likely the Y velocity increases in magnitude after the collision.